Okay, here we go into Module 5, Lessons 1 and 2. Welcome to class. So we've been talking about the slope-intercept form. Remember that anytime that you're dealing with the slope-intercept form, you've got to have the slope and you've got to have the y-intercept. Not the x-intercept, but the y-intercept. Remember, y-intercept is when x is equal to 0, not when y is equal to 0. So, here we go. We're going to look at this. Uh-oh, that doesn't have a y-intercept. So we better look up here. Is the point the y-intercept? Yes. Oh, then we keep on going. No, it's not on this one. Then you're going to plug the x, the y, and the slope into the slope-intercept form to find the y-intercept. So that's what we have to do first. So remember, we've got y equals mx plus b. This is my x value. This is my y value. I'm going to replace the y with 6, the m with 3/4, the x with -8, plus b. Now hopefully you remember how to cross cancel, because that'll make life so much easier. So when I do this problem, I'm going to get -6 plus b. Add 6 to both sides, and I get 12 is equal to b. Hooray, some of you might stop right there. But we don't have the slope-intercept form yet. All we have right now is we have the slope and the y-intercept. So we're still going to need to plug that into this equation. Y equals the slope, x plus the y-intercept. Now we have the equation in slope-intercept form. Next, we're going to do the exact same thing. Y equals mx plus b. We're going to replace the y, replace the m, replace the x to be able to find the b. So that will get me -10 plus b. Add 10 to both sides. I get 16 equals b. We are not finished. We have to plug that back in. Y equals the m, which is 2, and the b, which is, forgot the plus sign. There we go. And that is our equation. Okay, so now we're going to look down here. Marissa is baking a recipe that calls for her to turn down the temperature on her oven for part of the baking time. Write an equation to represent the situation if the temperature in her oven drops 25 degrees Fahrenheit every 30 seconds. And after 2 minutes, the temperature is 350 degrees. Okay, so the temperature in her drops 25 degrees every 30 seconds. Okay, and then we have 2 minutes is the temperature at 350 degrees. So what are we talking about? Normally time goes first, and then we have degrees. Oops. See if you can figure out what the point is and what the slope is. Okay, so the point is going to be 2 minutes and 350 degrees. What is the slope? Now, before I go to the slope, this time that was right here, this was in minutes. So I want this to be degrees per minute. So if I start with the degrees, it goes down. Baking recipe calls for her to turn down the temperature. So it's going to go down, okay, 250 degrees every 30 seconds. But 30 seconds is not a minute. 30 seconds is half of a minute, okay? So that means that my slope is going to be going down 50 degrees per minute. So if I plug this in, I need my y value is 350. My m value is negative 50. My x value is 2 plus b. Solve that and see if you got the same answer. 350 equals negative 100 plus b. Add 100, get 450 equals b. So now we found the y-intercept. The y-intercept means that that's where we started at. I plug that into my equation and I get y equals negative 50x plus 450 degrees. Okay? Do this problem on your own. Pause the video. Okay, so now let's look at it. It says the totally monthly cost of Isaiah's gym membership increased, so that means we're going up, by $5 per class she attends. Okay, that's a girl. So my slope is going to go up $5 per class she attends. She is signing up for 4 classes in 1 month. Her cost is $49.99. So, I did not mean to write right. So I'm going to plug this into my equation. $49.99 equals 5 times 4 plus b. So $49.99 equals 20 plus b, subtract 20. Because you guys should have already done this. I can go faster. And so my equation is going to be y equals 5x plus 29.99. Okay, next. Now we're creating a linear equation in slope-intercept form, but we're only given 2 points. We're not given the slope. So what we have to do is first get the slope. That's the very first thing I have to do. Oh no, there are decimals. It's okay. So I'm going to subtract 1.6 minus a negative 0.7 over negative 3.4 minus 1.2. I hate that thing. Okay, so when we do this problem, make sure that when you're doing this, that you don't actually subtract 0.7 because you have those 2 negatives. You're going to be adding those 2 numbers together. And then on the bottom, I would get a negative, wouldn't that be 4.6? Okay, 2.3 divided by 4.6. I'm going to get negative 0.5 or negative 1/2. Either one. Okay, then I'm going to pick a point. Oh, come back up here. Now, Is the y-intercept given? No. Okay, so I didn't put this up here, but you need to pick a point. It doesn't matter which point you want. You're just going to pick one of the 2 points. So if I was to pick the first point, I would do negative 0.7 equals negative 0.5 times 1.2 plus b. Okay, so I get, I don't know why I even did that. I get negative 0.6 plus b. I add, I get negative 0.1 equals b. Now, I'm actually going to plug in the second one just so that you can see that it doesn't matter which one you plug in. Oop, I forgot the negative. But make sure you actually put the negatives on there. And then negative 3.4 plus b. Oops, I went into that other problem. So 1.6. Well, that's going to give me a positive. 1.7 plus b. Subtract. Subtract. And I still get, it doesn't, sorry. Doesn't matter which one I used. I'm still going to get the same equation. So my slope is negative 0.5 x minus 0.1. Didn't matter which point I used. And no, you don't have to do it for both of the points. Either one of them will work. So over here, we're going to find the slope first. I want you to find the slope. Okay, negative 12 plus 3 over negative 7 plus 5. So that's negative 9 over negative 2. Then I'm going to pick a point. I'm just going to pick the first one because why not? Negative 5 plus b. Now, I can change this to 4.5 if you don't like the fact that that's a 5, or sorry, that that's a 9 over 2. It doesn't matter. But 4.5 times 5 is going to get me negative 22.5. I'm going to add that to the other side, add that to the other side, and get 19.5 is equal to b. So my equation, 4.5x plus 19.5. Could I write it as 9 over 2 x plus 39 over 2? Sure. Okay, now we want to know if this point is on the line. So in order for your point to be on the line, that means I have to plug in the point. Do you get a true statement? Okay, so I'm going to plug it in. I'm going to replace the y, negative 4. I'm going to replace the x, 2, minus 6. Negative 4 equals, I really just put 8. 4 minus 6. Negative 4 equals negative 2. Nope. Not on. Oh, that's how you spell on now. on the line. Okay? See how this came out to a false statement? That means it is not on the line. That means when you graph it, when you graph this line right here, this point right here is not going to be a point on that line. Okay, so then we come over and do this one. 10, I replace x with negative 3. 7, I replace it with 1. Do this problem. Negative 30 plus 7, does that equal negative 23? Negative 23 equals negative 23. Yes, it is on the line.